Hey, how's it going? This is Mr. Hernandez, and I'm here to guide you through these notes that we're taking today on exponential growth versus decay. So the first thing we're going to do with any notes is date it. This is the date for me. It might be different from you. We're in the end of Unit 2. And we're still dealing with exponential functions. And we're just focusing a little bit on growth and versus decay. So exponential growth, we're going to focus on doing that first. And pretty much we've seen that already in a graph. So if we just draw an x and y axis like this, it might pass through, let's say, a point 2, and it goes really low on the x-axis and then hits the y-intercept and then skyrockets. And you will have, this dotted line here, this boundary. It's called an asymptote. You could write that if you want to. Okay, and then we've also seen it already in a table where we have x and y. And let's just kind of get our first 3 or 4 terms here on our table. And you could pause it whenever you want, just so you have these notes down. So because our starting point here is 0, 0, 2, right here is where our starting point, or our y-intercept. So that is going to be 0, 2 is our y-intercept. And then let's say it, triples. Let's say that every time we go from one step to another, it triples. That is definitely an exponential growth. So we're going to have 6, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So that is an exponential growth. And then the last thing we have is an equation. So right here is our this right here is our y-intercept, or our starting point. And it grows by a multiple of 3. So the general form of the exponential function, the equation, is y equals a times b to the x, where this is our starting point, or our y-intercept, and b, or the base, is our multiplier. So if we plug in the values that we have here, our y-intercept is 2 and our multiplier is 3. So this would be the equation for an exponential growth. Okay, so let's look at a decay now. Exponential decay. So I would maybe start with the table first. So let's do that. Again, 0, 1, 2. So let's start with 50. And do you know? So what value would I multiply this by to get a smaller number? Well, it'll have to be something that would make it smaller. So maybe, half of 50 is 25, which, would be 0.5. So, and we could take half of that again, 12.5, if we multiply it by 0.5. And so if we apply that to the equation, our y-intercept would be 0.50 and our multiplier will be 0.5. And so that will be what we plug into this equation, y equals a times b to the x. So it's 50 times 0.5, or 1 over 2 if you want. It's the same thing. You could use one or the other. And then this would be kind of new to you when you see these, this graph here. So our y-intercept is going to be 50. So let's make that 50. That's going to be our y-intercept. And what the graph would look like is basically a flip of the exponential growth. So it's going to basically be going up from the left. So imagine this is really, really low, approaching the x-axis but never touching it. It's going to hit the y-intercept and then skyrocket up like that. But of course, if we read it from left to right, the story would be it skyrockets going down, but then it goes down slower and slower and slower. And you still have this asymptote here for the decay. But yeah, that's what they look like. So this graph for growth, it has a positive slope, whereas the graph of the exponential decay has a negative slope. And remember, slope is always read from left to right. So if this was a roller coaster, it'll be up, so you're going positive. This one would be down, so it's negative. And the table, the values increase, right, as you're going down the table. As the x values go up, the y values increase, whereas with an exponential decay, you have the numbers going down, decreasing as the x's go up. And then with this equation, you're really looking at this multiplier, and whenever it's a exponential growth, the multiplier is greater than 1. And here, when you have exponential decay, the multiplier is some decimal between 0 and 1. Because you could have a decimal that is like 1.5 or 3.5, and that's still going to make it grow because it's greater than 1. But if it's any decimal between 0 and 1, like 0.1, 0.2, 0.9, any of those decimals or fractions that are less than 1, greater than 0, it'll still be a decay. So that's basically the 3 different ways of seeing exponential growth and decay.